Hi, this is Mrs. Jones, and in this video I'm going to demonstrate dilations using GeoGebra and show you what happens to the coordinates when you use different scale factors. I have a simple triangle on the coordinate grid here, and I'm going to show the coordinates of each point so you can see what's happening as we make the dilations. And we're just going to use the origin as the center of the dilations for this exercise and in this class. If you use, of course, you can create dilations from any center, but the calculations to figure out what the coordinates will be a lot more difficult. So we're keeping it pretty simple in this class, just to in terms of the kinds of problems we'll be asked to do. So we're going to take this tool here up in the basic tools and create a point at the origin, and we'll be using that as our center of dilation. Alright, so the first thing we're going to do is go down to the transformation menu here, and the last option on the end is dilate from point. So we're going to select that tool. It tells us to select the object, then center point, and then enter a factor. So the triangle is our object, this point at the origin is our center, and then it asks us for a factor, which we call in our class a scale factor. And the scale factor is going to control how much bigger or smaller the image will be, and it also controls the location of it. So just for starters, I will put a value of 2 in there, and we'll see what it looks like. And there is our new image, the dilation. And you can see that the calculations are pretty simple on this. It's pretty easy to figure out. You're just multiplying all of the coordinates by 2. So 4, 4 becomes 8, 8. 4, 6 becomes 8, 12. And on point R here, 8, 4 becomes 16, 8. They're just all multiplied by 2. So the difficult thing in dilations is not so much figuring out what the coordinates are going to be, it's in imagining what it's going to look like, because it's not only twice as large as the original, they are similar figures, but no longer congruent because it's twice as large. But it's also twice as far away from the center of dilation. So let's do another one. We'll just get another example here. We're going to pick the figure and the origin, and this time we'll put in a factor of 3. And you can see up off the screen there our larger triangle up there. We'll back up a little bit, I guess, so you can see that. Okay, and again, just the original coordinates are all multiplied by 3. So 4, 6 becomes 12, 18, and so forth. Now, probably a more interesting example is what happens when the scale factor is less than 1. And so we'll do that. Let's just make it 1/2. Oops. Well, you can see the same thing applies. All the coordinates are just being multiplied by 1/2, and that makes them twice just smaller. So 4, 6 becomes 2, 3. 8, 4 becomes 4, 2. It's just a smaller triangle, and it's also closer to the center of dilation. One of the things that's a little bit interesting, if we take our original figure here, and we move it down so one of the points is on the actual x-axis, is you see that the other points are also on the x-axis. That's because they're being multiplied by different scale factors, but that 0 times the scale factor is still going to be 0. Also, when you pull it into another quadrant, all those points are going to still be in the same quadrant. So objects that are dilated, those points stay in the same quadrant where they started. And another thing that is kind of interesting about dilations is they don't have to necessarily be going out like that. If you put the center of dilation in the middle of, oh, we don't want to do that. In the middle of the screen, in the middle of the figure, I should say, then you end up with images that make kind of a bullseye effect, where they're just going inside and outside and surrounding each other. So that's another effect you can get with dilations. All right, remember you can come back to this and watch this video again if you need to review these concepts. And in the meantime, have fun making some transformations.